let's say if we have the function y is equal to 4 sine of 2x plus 7 plus 3, and you have to graph it. So how do you do this? So let's say that, just for visual purposes, this is right over here is our parent function. So this right over here is the graph of y is equal to sine of x. Right, this is our original function. Okay. Now, what you need to know about y is equal to sine of x is that the highest point is at y is equal to 1, and the lowest point is at y is equal to -1. It has an amplitude of 1. So the distance from the midline to the highest point is 1. It has a midline at y is equal to 0, and it has a period of 2 pi. So if y'all don't know what those vocab terms mean, well, I highly encourage you to check out. I have a video on kind of the different features of a sinusoidal function, so make sure to check that out. So in this video, I'm just going to assume that y'all know that. So for period, so that's going to be from, let's say, here to here. And then this right over here is a distance of 2 pi. Now, what I'm going to do is I'm going to highlight some points. All of these points I've highlighted, let's just call them critical points. And the reason why I call them critical points is because they're important. Now, notice how all of these points are either a point on the midline, a maximum point, or a minimum point. All right, so all these points I've highlighted are one of these three. Now, it turns out that sine functions are pretty nice, because what it turns out is that the distance from one critical point to the next critical point is actually the same distance as this critical point to this critical point. So it actually turns out that the distances, all of these yellow marks I've highlighted, the distances for each of them are going to be the same value. I haven't drawn this perfectly, but you kind of get the idea. And to find these values, right, to find the distance from one critical point to the next critical point, well, notice how, let me just redraw this. Notice how this is divided into 4 sections, right? 1, 2, 3, 4. And we know that this whole section right over here is 2 pi. So in one period of your graph, you're going to have 4 sections, right? So in order to find out the kind of length of one section, what you do is you're going to take the whole thing and you're just going to divide it by 4, right? So in order to find out the distance from one critical point to the other, what you do is you take your period and you divide it by 4. And that's going to give you the length of one critical point to the next critical point. So in this case, 2 pi divided by 4 just gives us pi over 2. What this means is that the distance from here to here is pi over 2. The distance from here to here is also pi over 2. So this point is going to be located at pi, right? Because pi over 2 plus pi over 2 gives us pi. This point is going to be at the coordinate 3 pi over 2, because pi over pi plus pi over 2 gives us 3 pi over 2. And notice how 3 pi over 2 plus pi over 2 gives us 2 pi. Let me deal with this plus 3 first. So imagine if we have the function y is equal to sine of x plus 3. What this is going to do is you're just going to take your sine function and you're just going to move it up by 3 units, right? So that's exactly what I'm going to do. I'm just going to take my sine function. I'm going to move everything up by 3 units. In this case, right, for our sine function, right, literally everything moves up by 3 units. So our minimum point, which was originally located at y is equal to -1, well, if I add 3 to it, now my new minimum point is going to be at y is equal to 2, right? And then for my maximum point was originally at y is equal to 1. So if I add 1 to 3, my new maximum point is going to be at y is equal to 4. Now, what does this 4 do? So imagine if I have the function y is equal to 4 sine of x plus 3. What this 4 does is, well, our amplitude, right over here, the distance between the midline, which in this case is 3, right? It's literally the line in the middle, right? Y is equal to 3. The distance from our midline to the highest point is 1. However, with the addition of the 4, what this does is now our distance between the midline to the highest point is now 4 units. So all I'm just going to do is I'm going to stretch this graph. It's going to look something like this. It's going to look something like this. It's not to scale, but it'll do the trick. So if I'm midline, so if my midline, let me just so notice how I haven't changed the location of my midline, right? My midline is still y is equal to 3, right? All I did was I changed the amplitude. In this case, if I go 4 units up from y is equal to 3, 3 plus 4 is 7, right? So that means our new highest point is at 7, right? Because that's our new amplitude influenced our highest point. And our amplitude is the same thing for, when we're going downwards. So actually, let me just move this down like this. Okay. And I also notice that the distance from the midline, notice how the distance from the midline to the lowest point is also 4 units down. Okay, right? Because our midline's at y is equal to 3, right? 3 minus 4 gives us -1, which is our new minimum point. So that's the thing about amplitude, right? The thing about amplitude is that now what happens is that your new maximum point is now 4 units up, but your new minimum point is now 4 units downwards than it originally was. So that's what kind of the amplitude does, and that's kind of how to graph it. Now, right over here, I have y is equal for sine of 2x plus 7. Now, I don't like the way that's written here, so let me fix this. I can rewrite this as y is equal to 4 sine of, in this case, whenever you see kind of a number that's not 1, so whenever the coefficient of this x term is not 1, so let's say if it's sine of 3x, sine of 4x, right? What you're going to do is you're going to factor out of this term if you see a horizontal shift term. So it's going to be sine of 2 times x plus 7 over 2 plus 3. So all we did was we just factor out a 2 term. Now notice how it's in the same format as the sinusoidal function kind of equation. So first off, let me deal with this 2. So imagine if I have the function y is equal to sine of 2x plus 3. What is this going to do? Well, this coefficient in front of this x term, this is going to influence the period. Originally, we said how the period is 2 pi, right? Distance from 2 consecutive points, or you can think about it as like the distance from one cycle, right? When the graph completes one cycle, right? That's 2 pi units. Now, what happens is this is going to influence our period, and the way that it influences our period is you're going to take 2 pi and you're going to divide it by the absolute value of this b term. So in this case, 2 pi divided by, in this case, 2 is just going to be pi. And this means that our new period is now going to be pi. So our new period is going to be pi units. Be pi, right? That's our new period for the graph. Now, finally, remember how I talked about like the whole critical points thing in like the beginning of the video? Well, this is going to apply now, because now what we're going to do, I know this point's supposed to be at -1, so let me fix that. Now, notice how, right, this point right over here is going to be located at pi over 4, at an x value of pi over 4. Because remember in the beginning of the video, we said how if we want to find a distance from one critical point to the next critical point, what we do is we take our period and we divide it by 4, right? And this gives us the distance from one critical point to the next critical point. So in this case, our period is pi. So pi over 4 gives us the distance from one critical point to the next critical point. This is going to be pi over 4. This point's going to be located at 2 pi over 4. This point's going to be located at 3 pi over 4. And finally, this is 4 pi over 4. We have to deal with this x plus 7 over 2. What does this do? 7 over 2. This right over here represents our horizontal shift. Remember back to graphing functions like y is equal to x squared. If I have something like y is equal to x minus 3 squared, you're going to move the function 3 units to the right. If this was x plus 3 squared, you move 3 units to the left. In this case, we have x plus 7 over 2. which means we're going to move 7 over 2 to the left. Now, before I move this graph, I just want you to pay attention to these points right over here. So watch these points. Remember this point right over here? It was originally at axis equal to 0, right? Remember this point? It was originally at axis equal to 0. Since we moved it to the left by 7 over 2, which is 3.5, so since we moved it to the left by 3.5 units, the new coordinate, the new x value of this point is going to be at negative 3.5. Right? Right, notice how originally our function, this point right over here, matches up with this point, right? And we moved this point to the left by 3.5 units. Now this point had an x coordinate of pi over 4. So if I moved it to the left by, 3.5 units, well, my new x coordinate is just going to be pi over 4 minus 3.5, right? Whatever this value is, let me actually search up this value. So pi over 4 minus 3.5 is going to be negative 2.7, around negative 2.7. And then for this point right over here, notice how it matches up with this point. This point was originally at 2 pi over 4. If I moved it to the left by 3.5 units, I'm going to get 2 pi over 4 minus 3.5. So 2 pi over 4 minus 3.5, that's going to be approximately negative 1.9. And you just keep doing this for every point. But you kind of see the pattern here, right? Just take whatever you had originally, match it up with what you have, and just subtract 3.5, right? Just do this for every single point. If it was a test and, the test was asking you to find a maximum point for this function, well, you have one right here. Negative 2.5, 7.